the examples related to beta function. Till now we have discussed the definition of beta function, various properties in which symmetric property beta mn is equal to beta nm, then expressing the beta function as an improper integral, combination of that two terms with the definite integration, relation between beta and gamma, trigonometric terms and various deductions, right? In between we did the proof of the property gamma n into gamma 1 minus n is equal to n upon sine n pi. So that is also covered in that with the help of the definition of the beta function or the definition of the beta function. So like now, using all this what we have learned, we will be now attempting several examples. So evaluate beta 7 by 2 comma 3 by 2. So I can compare it with beta m comma n. As I told you, there is only way of evaluating the connection between beta function or the examples given in the form of beta function via gamma function, because gamma function enables us to have the value, a definite quantity as the answer. So what relation I have? Beta mn is equal to gamma m into gamma n upon gamma m plus n. So beta mn will be gamma m gamma n upon gamma m plus n. M plus n means 7 plus 3 by 2, that is 5, and gamma 5 is nothing but 4 factorial, right? But how this numerator can be resolved? See, I told you when numerator is greater than the denominator, and mostly whenever it is by 2, you can try or think of the property which is n plus 1, gamma n plus 1. So 7 by 2 can be written as, take the difference of 2, 7 minus 2 is 5. So gamma 7 by 2 can be written as gamma 5 by 2 plus 1. 3 by 2 can be written as 1 by 2 plus 1, because 2 will be added in the numerator, right? So this is 5 by 2 plus 1, this is half plus 1. And gamma n plus n, gamma n plus 1 is nothing but n gamma n. So accordingly I can have gamma n plus 1 as n gamma n, n gamma n. Gamma half is the last one whose value is root pi. I don't have to think much about it. But still this gamma 5 by 2 is not resolved. Gamma 5 by 2 can be written as 3 by 2 plus 1. And then I can write it as 3 by 2 gamma 3 by 2. Gamma 3 by 2 in the last will be written as 1 by 2 plus 1, which is 1 by 2 gamma 1 by 2. So interconnected, you can easily try to simplify it one after the other. 7 by 2, 7 minus 2 is 5, so I can write it as 5 by 2 plus 1. Then 5 by 2 can be written as 3 by 2 plus 1. Then 3 by 2 can be written as half plus 1. And gamma n plus 1 is n gamma n. So accordingly we will be having the simplification. Gamma half in the last is nothing but root pi. Root pi is nothing but the result used for the gamma half. So accordingly you simplify. In the denominator it is gamma 4. Gamma 4 is 3 factorial. Directly you can write gamma 5 is nothing but इन्होंने लिखा है 4 plus 1, फिर उसको लिखा है 4 gamma 4, फिर 4 को लिखा है 3 gamma 3. Accordingly either वो भी कर सकते हो या directly gamma 5 is nothing but 4 factorial. 4 factorial is 4 into 3 into 2 into 1, and I can easily find out the answer. So beta 7 by 2 comma 3 by 2 can be easily simplified using the result beta mn as gamma m into gamma n upon gamma m plus n. So we have the result as, calculations आप कर लीजिएगा, that answer will be 5 upon 128 pi. So this was one example wherein we had to find out the answer for beta. Next question, many a times it is asked, sort of important one. Beta n comma 3 is 1 by 3, then find the value of the positive integer n. Now whenever we have a beta function equated with certain value, we can directly go with the relation between beta function and gamma function. So by using the definition or relation between beta and gamma function, beta n comma 3 will be written as gamma n gamma 3 upon gamma n plus 3, right? But this is equal to 1 by 3. gamma n can be written as n minus 1 factorial. In the denominator, gamma n plus 3 can be written as n plus 2 plus 1. So numerator may contains 2 into n minus 1 factorial upon n plus 2 plus 1. So gamma n plus 1 is n gamma n plus 2 gamma n plus 2. Again n plus 2 can be written as n plus 1 plus 1. So I can write it as n plus 1 gamma n plus 1, right? Go on simplifying till you get n minus 1 factorial. So gamma n will give you n minus 1 factorial, which can be cancelled from numerator and denominator. तो मेरा आंसर क्या बचता है? 2 upon n plus 2 into n plus 1 into n, and which is equated with 1 by 3. So simplify. What it will give you? It will give you the cubic equation. So 2 upon n into n plus 1 into n plus 2, which is equal to 1 by 3. 3 2s are 6. N into n plus 1 into n plus 2. Simplify. First two brackets will give you n square plus n multiplied by n plus 2 minus 6 is equal to 0. Cubic equation में one value of n is 1, another value is minus 2 plus 1.4 I. Complex नहीं चाहिए because n should be the positive integer. So what is the expected answer for n? Expected answer or the value for n is n should be equal to 1, and that is how we try to simplify and get the answer. So initially in the problem, if you see, it was beta n comma 3 is equal to 1 by 3. I use the result between beta function and gamma function. Go on simplifying. जब तक factorial cancel नहीं होगा unknown number का, we cannot proceed. So what I used is gamma n is n minus 1 factorial. N plus 3 can be splitted as n plus 2 plus 1. Apply the property. Gamma n plus 1 is n gamma n. So it became n plus 2 gamma n plus 2. N plus 2 is again written as n plus 1 plus 1. So it became n plus 1 gamma n plus 1. Gamma n plus 1 is n gamma n. Gamma n is n minus 1 factorial. From the numerator and denominator, n minus 1 factorial vanishes. I am left with the finite terms, and then you can simplify and get the answer. So neglecting the complex term or the imaginary roots, we have value of n as 1, which is nothing but the positive integer. So usually whenever numerator is greater than the denominator, I try to use the property of gamma n plus 1, because this into 1 will add up to the numerator, right? So always try to think in the manner that we will be having the terms 1 by 2 plus 1, that will be giving you 3 by 2, right? So half plus 1 यानी क्या रहेगा? 3 by 2. 3 by 2 plus 1 यानी क्या रहेगा? 5 by 2. Numerator gets added up, right, with the difference of 2 which is in the denominator. So in this way, whenever the numerator is greater than the denominator, plus 1 करते जाएंगे, तो आपको प्रॉपर्टी कौन सा यूज करना है? gamma n plus 1 as n gamma n. Gamma n plus 1 is n gamma n. Vice versa, when the numerator is less than the denominator, I will go for the property gamma n into gamma 1 minus n. The very next example is, from that it is evident that we will be using the property related to that. So in that case, we will be switching over to that example where the